Day 38, Honors Physics, Statics, problem number 1. Once again, I expect to see diagrams. The first diagram is sort of optional, but it's a free body force diagram for the point of concurrency, so it's a force diagram. We're not drawing the force diagram for the heavy traffic light, but we're looking at the point of concurrency, and there's 3 ropes essentially attached. Well, there's the horizontal cable that's been deflected, and the angles are indicated on the diagram. So I'm looking at point A, the point of concurrency, to draw my force diagram. And the 2 angled ropes, so to speak, the cable, are each, or basically that cable has 1,000 newtons of tension at maximum. We're setting it to the maximum because that's where it could possibly break. So we want to see the maximum weight we can put at the bottom there for that traffic signal, such that there's 1,000 newtons of tension in that cable that it's hanging on. So bottom line is, though, what we really want is our component diagram. The one on the bottom left diagram is the one we want. W is straight down, that's good, but the 2 angled tensions can be broken into components, and I did that over here on the right hand side. So I show my component diagram where I have 1,000 Newton tension in the far right over here with the proper components, where you have the X component here, the Y component here. I calculated those out, and I have the X component was 985. This is for the right hand cable pointing to the upper right here, but I didn't draw the diagram for the other 1,000 Newton tension for the one that's going up and to the left, because it's the same numbers. And what's going to happen is the 2 X components are going to cancel out. If you look at the final diagram here on the lower left, this X component over here, which I didn't calculate, which would be the same as this X component right here, those will cancel out, because once to the right, once to the left, they're 985 newtons, they'll cancel. But W down here has to be the sum of these 2 guys, and these 2 guys are equal to each other because of the symmetry of the problem. So basically you just take the Ty sub 1, which is 174, and double it to get your final answer, and that's the maximum weight you can put on this cable.